Hello students. Today we will discuss about nanomaterials, which are the central point of nanoscience. Nanoscience is the science of nanoscale. Nanoscale means to very lower level, that is to nano level, where 1 nanometer is considered to be equivalent to 10 raised to minus 9 meters. The present century is considered to be the era of nanoscience and nanotechnology, and in every field, people are talking about nanoscience and nanomaterials. But this branch of science is not a new topic. It was known from earlier days. For example, some of you may be familiar with the Lycurgus cup, which is now present at the museum at London. The importance or the fascination of this cup is that it will display different colors depending upon the source of light placed. If the source of light is placed outside and viewing the cup, it will display in one color. But if you are keeping the source of light inside the cup and viewing the cup, it will display some other color. Such fascinations were there from the earlier times. Those who are interested, you can Google the fascinations of nanomaterials of earlier chapters. So today we will make some discussion about nanomaterials. Nanoscience means science at the nano level, and materials with the nano dimensions exhibiting certain peculiar properties are called nanomaterials. As I told you, nanomaterials are materials with nanoscale dimension, and nanoscale dimension means 1 to 100 nanometers. These materials will show entirely different properties from the bulk materials, and the new properties shown by nanomaterials are quite explored by scientists and many people working in this field. So nanotechnology deals with the building and using making up of materials from bulk or making new materials in the nanoscale dimension and using these material devices at the nanometer scale to exploit their unique properties. 1 nanometer is 10 raised to minus 9 meter or 1 billionth of a unit. Nanomaterials are classified in different ways, but one of the most popular way in which this classification is done is confined to the nanoscale range associated with the different dimensions of these particles. For example, those materials where the dimensions are measured, all the dimensions of the material are measured within the nanoscale. That is, no dimensions are larger than 100 nanometers. All the dimensions of the material falls within 1 to 100 nanometer range. Such materials are categorized as zero-dimensional nanomaterials. And if one dimension of a material is outside the nanoscale, that is greater than 100 nanometers, for example, nanotubes, nanorods, or nanowires, etc., they are classified as one-dimensional nanomaterials. And if two of the dimensions are not bound to nanoscale, means two of the dimensions of the material are greater than 100 nanometers, they are classified as two-dimensional nanomaterials. And if all the dimensions of a material are greater than 100 nanometers, such materials which are visible to our naked eye, they are known to be three-dimensional nanomaterials, and in the common language we call these type of materials called it to be bulk materials, which are more common to us. Now at this point we can compare what is a nanomaterial versus a bulk materials. Okay? When the particle size decreases, that means that we are starting from a huge material object, a bulk material, and we are reducing the size, the number of atoms on its surface increases. Means the surface to volume ratio increases. A size reduction while we are reducing the size to 3 nanometer, then there occurs a surface atom, number of atoms at the surface to be increased about 50%. What will be the net result? There is a very huge surface to volume ratio, or the surface area, effective surface area will substantially increase, which will lead to various different, beautiful, or unexpected, unique surface phenomena. When the diameter of a, for example, when the diameter of a particle equals to the wavelength of electron wave function within physics, quantum confinement, the process is or the phenomenon is said to be quantum confinement, which leads to an increase in the energy difference between the energy levels and energy band gap. Band gap is a very familiar term for people working in the photophysical, optoelectronics, and physics background, which is the most important property that we are always looking for. Different optical and electronic properties. For example, gold in nanoparticles. Nowadays, we know gold is also said to be the yellow metal, which is yellowish, golden yellowish in color. But when we are reducing the size of these bulk gold particles to nano-size dimensions, it will appear as red particles. Now, how we can synthesize these potential nanomaterials? There are basically two approaches are there, top-down and bottom-up. I'm not going into the details of these synthesis methods. Top-down, as the name says, we are making these nanomaterials from the bulk particles. We are reducing the size of the bulk particle to the nanoscale dimension. And another method approach is a bottom-up approach, where we are taking the particles in the atomic size and building up atoms together or molecules together to convert it into a nanoscale dimension. Now, what are the applications? Why we are saying that nanomaterials are so important? Because it finds applications in every field. For example, in biology and medicine, we can use the detection of tumor cells can be made very effectively and very efficiently by nanomaterials. One of the major problems suffered by cancer patients is the side effects of various potential drugs used during their chemotherapy treatment. So, for such patients, their body parts which are not affected by cancer will also be affected as a part of the side effect caused by the powerful drugs administered to such patients. Nanoscience offers a method to deliver cancer drugs at that particular points where the cancer is affected, so that the side effect can be reduced. Then in various biochemical analysis, nanochips and therapeutic agent industry, therapeutic agents, nano robots can be employed as therapeutic agents. In electronics, we know that in every day the size or dimension of electronic equipment, appliances are decreasing, which is possible with these type of nano materials. Food packaging, nano sensors and disinfectant. Now, during the time of COVID, disinfectant is very important. In the energy sectors, the most promising sector for nanomaterials, rechargeable batteries, and in solar cells, nanomaterials finds wide applications. And these nanomaterials, there is a negative part also. It is somewhat toxic, and hence the study of the toxicity associated with the nanomaterials, which is known to be nanotoxicology, is also developing along with the nanoscience. I will only cite certain health issues related to the nanomaterials in the brain. Alzheimer's and Parkinson's disease may be caused with the contact of nanomaterials, lungs, cancer, asthma, bronchitis, blood pressure variation, vasoconstriction that may be affected to gastrointestinal systems, and almost all parts will have adverse effect with the nanomaterials also. That is why the toxicity should be studied before its application. Okay, thank you.